In this video I'm going to show you how to find the area element in polar coordinates in 3 simple steps. Suppose that we have a double integral for an area in Cartesian coordinates, so it's going to use the variables x and y and the differentials dx and dy. Then the differentials form an area element because this is a very small length and this is a very small length, and length times length gives us an area. However, if we transform this integral into polar coordinates, the differentials are obviously also going to reflect the variables of the respective coordinate system, so in our case r and phi. But the problem is that's not an area. Just thinking in terms of dimensions, this is a length and this is an angle, and length times angle is never going to give us an area. But for the integral to work, this needs to be an area. So we need an additional factor that we can multiply with those differentials that makes this thing an area element. And the way we're going to find that factor is the following. Firstly, we're going to have to find the Jacobian of the transformation. In our case, from Cartesian coordinates into polar coordinates. We already did exactly that in a previous video, so I will link it in the description below, and we can treat the Jacobian as given for this video. Secondly, we're going to have to calculate the determinant of the Jacobian. And thirdly, we're going to have to multiply that determinant with the differentials dr and dphi. And that product is our area element for polar coordinates. Since we already have the Jacobian, which is this one, we're going to jump right into step 2. The determinant of a 2 by 2 matrix is this diagonal multiplied minus this diagonal multiplied. So let's do exactly that. Firstly, we have cosine phi multiplied with r cosine phi. So we're going to get r cosine squared phi. Then we're going to subtract the product of the second diagonal, which is sine phi times minus r sine phi. Since we have a minus here too, that's going to turn positive, and it's going to give us r sine squared phi. As most of you probably know, there is a trigonometric identity saying that cosine squared plus sine squared equals 1. And we can use that here because both have the same factor, which is r. So we're going to factor out that r so that only cosine squared phi plus sine squared phi remains. This is just going to reduce to 1. So we're left with just r. This r is the determinant of the Jacobian matrix for this transformation, and thus the factor we need to multiply to our differentials in order to give us an area. The r we just found is going to go right here, so the area element for polar coordinates is r dr dphi. I really hope you found this video helpful and got some value out of it. If yes, you know what buttons to click. Otherwise, I'm always open for feedback, just put it in the comments down below. And if you have any ideas for videos, for topics that you would like to see me cover, just put them there as well. Thank you so much for watching and see you in the next one.